Good wishes, dear students. So far we have seen what's a mineral and ore and how to find out the difference between them, then the types of ores, then concentration of ores, meaning removal of impurities present in the ore, and after that we moved on to the steps called extraction of ores, and under that you learnt about roasting, calcination, smelting, reduction by different reducing properties. Now we are moving on to the fourth concept in this lesson, refining process. What's the meaning of refining process? Obtaining a pure metal. Here again you have four different methods possible: distillation, liquefaction, zone refining and vapor phase method. We will see one by one in detail. To give you a short definition of the refining process, removal of impurities like unreacted oxide ores, other metals, non-metals, etc. from isolated crude metal is called a refining process. I have told you every now and then, during the concentration of ore, certain types of impurities are being removed. When we move on to the extraction of ores, in the process called smelting, if you remember, flux plus gangue gives you slag. Slag is another form of waste material is being removed. Now, after all these procedures, there will be some more traces of impurities left behind or mixed with a crude metal. So, removal of such impurities is called as a refining process. The first one is a distillation. I have given in short the necessary notes for you all. This method is applicable for low boiling volatile metals. According to your syllabus, two examples have been given. One is a zinc, the other one is a mercury. Impure metal is heated to evaporate and the vapors are condensed to get a pure metal. Now you have learnt about distillation in your lower classes. Impure metal is taken and when the heat is applied, it gets evaporated. The vapor that comes out is being condensed and collected in the form of a liquid. So this is called as a distillation, applicable for the low boiling volatile metals. Now we move into the second type, that is liquefaction. Now liquefaction here, impurity should have the high melting point and the metal should have the low boiling point. Low melting point. Here the condition is distillation is suitable for the low boiling volatile metal. Liquefaction is suitable for those crude metals in which impurities will have a high melting point, metals will have a low melting point. Now here what happens, I'll just try to show you the small diagram of it. This is a type of furnace is called as a reverberatory furnace, meaning it is capable of withholding high temperature. Now impure metal is taken here. When you pour it, the furnace is being heated. When you pour it along the sloping surface, we have told you impurities have a high melting point. Pure metals have a low melting point. So the impurities will remain back. The pure metal which has got a low melting point will start melting and being collected in the container next to the reverberatory furnace or within the reverberatory furnace. So put it in a points for you all to understand. So in this procedure, reverberatory furnace is being used in that when you take a crude metal and when you supply heat, it becomes a fusible liquid. When the fusible liquid is made to run along the sloping surface, the impure metal remains back, the pure metal runs down and gets collected. So in this method is applicable for tin, lead, mercury and bismuth. So now we'll move on to the third type of refining process, that is electrolytic refining. In exam point of view, this method is quite very important. Now electrolytic refining, the term electrolytic only you remember, cathode should be there, anode should be there, electrolyte solution should be there. So in at cathode you take a pure silver rod. Now cathode will have a negative charge. Anode you take a impure silver rod. Anode will have a positive charge. The solution that you take should be acidified aqueous solution of silver nitrate. Now again to explain to you with a diagram, I have taken the electrolytic setup I have taken. two types of rods I've got. That is, one is at anode I have an impure silver rod, since we are studying about the extraction of silver metal. At cathode I've got a pure silver rod. The electrolyte solution is of silver nitrate solution. It's aqueous solution of silver nitrate I have taken. When the charge is being passed here, the silver ions, it's an impure silver rod. The silver ions from here will move into the solution, and from the solution they will get moved to the cathode. So as a result, as the procedure goes on and on, one by one the silver ions will move to the cathode, leaving behind only impurities present at the anode. So I have given the reactions here. Reaction at anode. So impure silver you take, when the charge is being passed, the pure silver ion gets separated. Reaction at cathode, the pure silver ions which comes out of the anode gets collected at the cathode. So as a result, at the end of the thing, you will see in the beginning, at anode the silver rod will be bigger in size. At cathode the pure silver rod will be smaller in size. At the end of the experiment, this one will be a smaller, this one will be the bigger, meaning all the pure silver ions will get moved to the cathode, leaving behind only impurities. So only so much you have to study under electrolytic refining. The other metals which can be extracted by these methods are copper and zinc. Now we are moving on to the next one, zone refining. Here the principle used here is fractional crystallization. So I'll just tell you in simple word, you're showing the diagram. A impure metal rod is taken. A electric heater, I'm sorry. Diagrams are not important, children, only for you to understand the concept. So here an electric heater is taken. The heater is made to run along up and down the rod again and again. What happens here is, I'll just give you by these points. Impure metal rod is taken. When we heat it using the mobile induction or a heater, melting of the metal takes place. Now once the metal starts melting, pure metal gets crystallized, becomes solid. Impure metals remains in the molten state, and as you move the heater up and down, the impure metal, which is in the molten state, keeps moving from one end of the rod to the other end along with the heater. So this procedure is repeated again and again till we obtain the pure metal. At the end of it, all the impure metal will get collected on here, and the pure metal will get collected here. So this part of the rod will be cut and taken out. So this is the principle involved in zone refining process. Last,
I gave you my heart.